Good morning, students. In the previous class, we discussed about the vapor pressure of liquid solutions. Vapor pressure of liquid solutions and Rolle's law we are discussed, and along with we are discussed about the Rolle's law in the special case of Henry's law we are discussed in the previous class. In this class, we are going to be discussing about the vapor pressure of solution of non-volatile solute in a volatile solvent. That we are going to be discussing in this class. That is vapor pressure. Vapor pressure of solution of non-volatile solute in a volatile solvent. In this class, we are going to be discussing about the vapor pressure of solution of non-volatile solute in a volatile solvent. In this, already we know that we are discussed, that is the pressure exerted by the vapors of the liquid. The pressure exerted by the vapors of liquid is called as a vapor pressure, that we are discussing. Now we are going to be adding the non-volatile solutes. That is non-volatile solutes. Example for non-volatile solutes is urea, then sodium chloride, that is common salt, sugar is going to be added to the volatile solvent. We are going to be taking an example water. Then to form a aqueous solution, means we are adding the non-volatile solutes, like that is urea, sugar, then salt. Any non-volatile solute is added to the volatile solvent, that is water, is going to be form a aqueous. This is going to be form a aqueous solutions. At that time, the vapor pressure of the solution, we can be observed. That is, we can observe that the vapor pressure of the solution is less than the vapor pressure of the pure solvent. Why it's going to be lower is the vapor pressure? Because the first, it contains only the volatile solvent. This is a volatile solvent. It contains the volatile solvent. For that, we are going to be adding the non-volatile solute. Think it is a volatile solute. It's going to be volatile solute. We are going to be non-volatile solute is going to be added to the volatile solvent. Means here the white, whatever I mentioned in the white chalk, that is the solvent. Here we are going to be taken up as a water. Then what I mentioned in the orange color, that is, you just consider that it is some solute, that is non-volatile solute, that is urea, salt. We will take the salt. Okay. Why is it? Because the vapor pressure is vapor pressure of the solution. That is vapor pressure of solution is less than the vapor pressure of solvent. Why? Because of first it contains the only solvent, that is volatile. Therefore, the vapor pressure is more. When we are adding the salt, that is non-volatile, it is the surface of the solution. Before adding the salt, it contains all the molecules of solvent, volatile molecules. Then when we are adding the non-volatile solute, that is the some of the surface of the solution it occupies by the non-volatile solute particles. Therefore, the vapor pressure of the solution is decreases. Vapor pressure of the solution is decreases. This can be, that is vapor pressure of the solution of non-volatile solute in a volatile solvent is stated by Rolle's law is, it states that relative lowering of vapor pressure, is equal to the mole fraction of the solute in a volatile solvent. This is about the statement, that is the statement of the Rolle's law in the case of, that is vapor pressure of solution of containing the non-volatile solute in a volatile solvent. Means in this you should be remember that the first it is contained the vapor. What is meant by vapor pressure? The pressure exerted by the that is vapors of the liquid is called as vapor pressure. Then in this case we are adding the non-volatile solute. Non-volatile solute is added to the volatile solvent. ಅಂದ್ರೆ ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲ್ಯೂಟ್ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, ವಾಲಟೈಲ್ ಸಾಲ್ವೆಂಟ್ ಗೆ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲ್ಯೂಟ್ಸ್ ಯಾವುದು? ಇಲ್ಲಿ ಯೂರಿಯಾ, ಸಾಲ್ಟ್, ಶುಗರ್ ಇವೆಲ್ಲ ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲ್ಯೂಟ್ಸ್. ಇದನ್ನ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, ವಾಟರ್ ಗೆ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಯಾವಾಗ ವಾಟರ್ ಗೆ ಆಡ್ ಮಾಡ್ತೀವೋ at that time what happens is going to be the vapor pressure of the solution is decreases when compared to the pure solvent. Pure solvent ಏನಾಗಿರುತ್ತೆ, volatile ಆಗಿರುತ್ತೆ. escaping capacity is more in the volatile solvent. At that time when we are adding the non volatile solute, at that time the surface is occupied by that is non volatile solute particles. At that time the pressure is going to be decreases. ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ the vapor pressure of the solution is decreases when having the less than the vapor pressure of the solvent. This has stated in the Rolle's law. This explanation is given by that is Rolle's law. That is a relative lowering of vapor pressure. Relative lowering of vapor pressure is equal to the mole fraction of the solute in a volatile solvent. This about the vapor pressure of the solution of non-volatile solute in a volatile solvent. Now we are going to be discussing about that is next concept, that is the ideal and non-ideal solutions. Ideal and non-ideal solutions. The first, now we are going to be discussing about the ideal and non-ideal solutions. Non-ideal solutions. Now we will discuss about the ideal and non-ideal solutions. The solutions on the basis of Rolle's law, the liquid solutions are classified into two types. That is ideal solutions, and the next one is we call it as a non-ideal solutions. The first we are going to be discussing about the ideal solutions. We will discuss about the ideal solutions first. Ideal solutions means the solutions which obeys the Rolle's law. The solutions which obeys the Rolle's law, that is Rolle's law under all the conditions of temperature and the concentration. Under all the conditions of that is temperature and the concentration is called as ideal solution. A solution which obeys Rolle's law, in all the conditions of temperature and the concentration is called as ideal solution. Now we'll discuss about the characteristics of ideal solution. The first characteristics, which obeys the Rolle's law. Which obeys the Rolle's law. Then the enthalpy change of the solution. The enthalpy change of the solution always is equal to the 0. Means the enthalpy does not change when compared to that is the solute and the solvent and the solution. The enthalpy will not be changed. The change in the enthalpy is 0. Then the change in the volume. The change in the volume of mixture is equal to 0. Is equal to 0. Means what it indicates? The volume of the solution. The volume of the solution is equal to the sum of the volumes of the two components. Sum of the volumes of the two components. Means the solution means it contains two components. Means component A, component B. Here going to be taken that the volume of the solution. The volume of the solution is equal to volume of A plus volume of B. At that time, there is no change in the volume. Then we can take an answer. The change in the volume is equal to the 0. It's another characteristics of the ideal solution. Then the interaction of, that is if you are going to be solute-solute interaction, if suppose A is a solute, if you are going to be taken as A is a solute, then B we are going to be taken as a solvent. At that time, the interaction of, that is AA, that is solute-solute interaction, or the solvent-solvent interaction is same in, that is solute-solvent interaction. The solute and solvent interaction. This about the another point of the ideal, the another characteristics of the ideal solution. Means here there is no enthalpy change. Enthalpy change of the solution is equal to the 0. The change in the volume is equal to the 0, and the interaction of solute-solvent or solvent-solvent is same as of the solute-solvent. Then this about the next characteristic, and one more thing we are going to be discussing about the one more characteristic is total pressure of the solution is equal to the sum of partial pressures of the solute and the solvent. Means total pressure of the solution. Total pressure of the solution is equal to the pressure of the solute, partial pressure of the solute and partial pressure of the solvent. Means here the total pressure of the solution is equal to the sum of partial pressure of the that is the solute and the solvent. The example for this is this type of ideal solutions. Example for this is N-hexane, N-heptane is an example. Benzene, toluene is example. A pair of solutions. That is first one is example for the ideal solution is N-hexane, N-heptane. Then benzene, toluene. The benzene, toluene is an example. Then one more thing is bromo, benzene, chlorobenzene is an example for the ideal solutions. Example for the ideal solutions. This is about the ideal characteristics of the ideal solution. The next we are going to be discussing about the non-ideal solutions. Non-ideal solutions. When it comes to the non-ideal solutions, in this which does not obey the Rolle's law. Non-ideal means a solution which does not obey the Rolle's law. It does not obey the Rolle's law. Entire range of the concentration. Entire range of the concentration is called as a non-ideal solution. Then the change in the enthalpy is not equal to 0. That is the change in the enthalpy is not equal to 0. Then change in the volume is not equal to 0 means it changes the enthalpy. It changes the volume. Either it may be decreases or increases. The volume of the solution is decreases or increases. Means it is not equal to the 0. Then the interactions, that is the AA interaction, BP in B, that is the solute-solute interaction. Then solvent-solvent interaction is different from that is AB interaction means solute-solvent interaction. There is another difference. Then total pressure is not equal to the sum of the partial pressures of that is solute and the solvent. This about the characteristics of non-ideal solution. It is the reverse, that is of the ideal. Means the ideal solution obeys the Rolle's law. Non-ideal solution does not obey the Rolle's law. Then the change in enthalpy is equal to 0. The change in enthalpy is not equal to 0. Change in the volume is equal to 0. Change in the volume is not equal to 0. Maybe less than, maybe decreases, maybe increases. Then the interaction of solute-solute, solvent-solvent interactions is same as in the that is solute-solvent interaction. But solute-solute interaction, solvent-solvent interaction is different from the that is solute-solvent interaction. Then total pressure of the solution is equal to sum of the partial pressure of the that is sum of the partial pressure of the solute and the solvent. The total pressure of the solvent is not equal to the sum of the partial pressures of the solute and the solvent. This about the differences between the ideal solution and the non-ideal solutions. In the next class, we will discuss about the types of non-ideal solutions.